Good morning, everyone. Mr. Shields here, starting out with our very first digital lesson here on simplifying radicals here. If we take a look at this topic, it's actually not a new topic. It's something we've actually covered before. We're going to have 12 different lessons from now until the end of the school year here. So we wanted to start off with something that I think most of you guys did pretty well as far as simplifying radicals are concerned. So before we begin, make sure you have something to write with, a pen or a pencil, and a sheet of notebook paper so that you can copy along with me as I go over various problems. So let's go ahead and get started with our lesson here on reducing these radicals. So if I highlight perfect squares, that's a very important thing as far as this is concerned. And you'll notice that I wrote out my perfect squares from 1 through 169. Now, where did I get those numbers? I didn't just make those up. I actually took the time. 1 times 1 gives me 1, 2 times 2 gives me 4, 3 times 3 gives me 9, and so on. And that's how you can go ahead and get your list of perfect squares. So we're going to need those in order to simplify problems that aren't perfect square roots. So if I take a look at the very first problem up here, the square root of 16, well, the answer is just 4. But what happens if you have something that isn't perfect? So for instance, if I were to take the square root of 32, for instance, I would end up with a decimal. Now, I don't want to have a decimal for my answer. Instead, I want something to look a little bit different than that. So if I take a look at my very first section up here, parts of a radical, and I have it labeled here, I have the index, I have the radical symbol here, as well as the radicand. And so what we're going to do is try to simplify the number and then later on the variables under that radical sign. So if I take a look here at the square root of 32. Now, the first thing I need to do is draw my little arrows, because I'm going to try to break those apart. And then once I've drawn those arrows, you see that I've written the radical sign. Now, the first step is to find the largest perfect square that can divide into that number. Okay? So I could choose 4 as a perfect square, and I would do 32 times 4, and I would get 8. But the problem with that is I want the largest. So not just the first one that comes to mind. And so with that in mind, I know that the largest perfect square to go into 32 just happens to be 16. Now, one thing that when we're doing the problems like this, I always want to write my perfect square on the left-hand side. It just makes it easier for what's going to come next. Now, what about the other number to go into this radical sign? Well, 32 divided by 16 is just 2. Okay? So once we have those two numbers, then we can take the square root of them. So the square root of 16 is just 4. And once I take the square root of a perfect square, the radical sign, you'll notice, disappears. But what happens if I were to take the square root of 2? Well, I'm going to go ahead and put that in the calculator right now, and you will notice that I will get a decimal. I don't want a decimal, so I'm just going to keep it as is. So in other words, I'm just going to bring down the square root of 2, and that will be the end of that. Okay? Let's do another one. If I take a look at number 6 here. So there are a number of different options that I can choose, but because I want the biggest perfect square, I'm going to target in on number 36 here. Now, how do I know that's the biggest perfect square? Well, you're probably going to have to do some trial and error. So in other words, I'm going to go in my calculator and maybe I'll do 180 divided by 9. Hey, that works. But is there something bigger? Well, I could always do 180 divided by 16. That doesn't work. But if I were to go ahead and do 180 divided by 36, what do you know? I have 36 as my perfect square, and my other number that's going to go under the radical sign being the 5. Okay? And so another way of thinking of it is 180 divided by 36 will give you the 5. Okay? And then I can just take the square root. So the square root of 36 is just 6. If I take the square root of 5, and I'll go ahead and put that in my calculator right now, and I get a decimal. I don't want that, so I will just go ahead and keep it as the square root of 5. Okay? Taking a look at number 7. And if I look at number 7, I got 147 as my number. And so I want to find out what could be my biggest perfect square. Now, I could go over and search on the calculator and divide each of them out until I eventually got at a number. But since I've prepared this ahead of time, I know that my number just happens to be 49. And then once I know what my biggest perfect square is, I can just go ahead and divide. And so my other number just happens to be 3. So the square root of 49 is just 7. But if I take the square root of 3, you'll notice that I end up with a decimal. So I don't want the decimal, so I will just keep it at the square root of 3. And that is my final answer here. Looking at number 8, I'm going to do it pretty much the same way here. I'm going to try to find out what my biggest perfect square is that will divide into it. And I know that 25 just happens to be the biggest perfect square. And what I would do, as I mentioned before, is just kind of search until you find that biggest perfect square. You might have to divide a few times in order to get it, but you will get it if you stick with it. And so then 7 is going to be my other number, 175 divided by 25. I know the square root of 25 is just 5. And if I were to do the square root of 7, I would end up with a decimal. And so I'll just keep it like so. I'm going to go on to number 9 here. And so if I look at 48, there are quite a few of these perfect squares up top here that will actually go into 48. I could use 4, that would work. But I know that's not the one I want because there's something bigger than 4 that can go into 48. And that number just happens to be 16. And once again, you play around with it in the calculator until you find that biggest perfect square. So when I know that, 48 divided by 16 is going to give me 3. So my other number under the radical sign will be a 3. I take the square root of each of these numbers. So the square root of 16 is just 4. But if I do the square root of 3, once again, you probably guessed it, I'll have a decimal. So I don't want that. I just want to keep it as so. Let's take a look at number 10. You'll notice that one looks a little bit different because there is a number on the outside of the radical sign. But we're still going to do it the same way, only our last step is going to look a little bit different. So let's take a look. We're going to draw little arrows. Going to have our radical sign here. If I can keep it together here. We're going to have our radical sign here. And I'm going to try to find my biggest perfect square. And my biggest perfect square, interestingly enough, is just the number 9. Okay? And so when I do 54 divided by 9, I'll put that in my calculator, and I will get 6. So I know my two numbers are 9 and 6. But once I take the square root of each number, so the square root of 9 is 3. The square root of 6 is going to give me a decimal, so I'll just keep it that same way here. But I'm still not done because I have that 2 on the outside. And I'm going to drag down that 2 because what I'm going to have to do is take that 2 and multiply it by the 3 that's on the outside. So 2 times 3 just gives me 6. Okay? All right, so that's the very first set of problems. Like I said before, you probably already know how to do these, or at least are a bit comfortable with these. So hopefully that's not too much of a challenge. But what about if we have a variable on the inside? Well, let's go to a different piece of paper here, and we'll go ahead and tackle that.